Okay, can you see my screen? Okay, thanks, Heather. So, good morning, afternoon, or evening to everybody. Thank you very much for joining us. This is the 17th NANO webinar. Before we start, I would always like to introduce some new attendees to what is NANO per se. So NANO is the acronym for the NF POGO Alumni Network for the Ocean. We are a network of former and current scholars of NF POGO Capacity Development Program. And the objective of the network is basically maximize the benefit of the training, meaning strengthen our networking skills among the alumni and instructors, support joint activities such as outreach and research projects. And NANO started in 2010. It's supported by POGO and the Nippon Foundation. And one of the main activities we have right now is the NanoDope research project. If I can just change slides, there you go. So the NanoDope project intends to create a network of coastal monitoring stations that are supported with support from financial support from POGO and Nippon Foundation, but mainly this work is led by our alumni. And currently we have 35 stations, monitoring stations in 18 countries. And our alumni is responsible for collect monthly or bi-monthly some of the essential ocean variables, mainly temperature, dissolved oxygen, pH, chlorophyll, and salinity. But the project also encompasses a strong outreach and capacity development in the activities. And this NANO Webinar Series is part of these activities. So today we welcome Professor Heather Koldewey from the Exeter University and the Zoological Society of London, United Kingdom. Heather has worked for the Zoological Society of London since 1995 as a postdoctoral research scientist and head of Marine and Freshwater Conservation. And now she's a senior technical advisor. She's the Honorary Professor at the University of Exeter and National Geographic Explorer with a focus on solving ocean plastic pollution. She was science co-lead for National Geographic's 2019 Sea to Swords Ganges expedition. Since 2017, Heather has led the Bertarelli Foundation's Marine Science Program, a transdisciplinary research and conservation program for marine science and conservation focused on the Indian Ocean. As the other episodes of the NANO Webinar Series, this is being recorded and later will be posted on YouTube. This QR code here can direct you to the playlist on our YouTube page. And so we welcome Heather to present in the next 30 minutes. And then we will open to the audience for questions. So you can raise your hand, and once we say your name, you can switch on your mic and ask the question directly to Heather, or you can post it in the chat and we can read it for her. So thank you again for joining us, and thank you, Heather. Feel free to share your screen.
Thank you so much, Lynn. Can I just confirm you can see that in presentation mode?
Yes, perfect.
Great, hooray, right, first time. Well, it was a real honor and privilege to have the invitation from Subrata, who I've worked with for the last few years, to join this webinar series. And thank you so much, everybody who's attending from various parts of the world today. It's great to see this alumni network so engaged, thinking about ocean science. So my presentation today was really to focus on ocean optimism in a sea of plastic. We obviously know there's been a huge rise of plastic over the years since it was first really invented in the 1950s. And without breaking down this graph, just to see the dark pink bit at the bottom shows single-use plastic, particularly used for packaging. And that's about half of the plastic used every year or manufactured every year is for single-use plastic. And this really came from the 1950s when we thought this was this amazing product of throwaway lifestyle, was just solving all of the problems that we had. And what's interesting is this was a Life magazine in 1955, but obviously the adoption of single-use plastic across the globe has been quite different in terms of pace. So in work that I've done with Subrata and other colleagues, places like India and Bangladesh, we're more looking at single-use plastic really becoming mainstream just in the last 20 years. We do have a global waste problem in that this remarkable product doesn't just go away. And in fact, none of our waste really disappears. We just either are looking at waste management that's disposing of it, or we're having to deal with it, or it's entering the environment. And as was mentioned, I was science co-lead with Professor Jenna Jambak from Georgia University, and this was her real seminal paper in 2015 that looked at plastic waste inputs from land into the ocean and where was the plastic going, estimating between 8 and 12 million tons of plastic is going into the ocean every single year. And what we now see is plastic everywhere that we've looked. So as researchers, we've as we look across the ocean, from the deepest point, the Marianas Trench, to the highest place on Earth, Mount Everest, we've found plastics, and we see it aggregating in certain areas known as gyres across the ocean. But we're really dealing with a global problem that's being distributed from countries, from land, from rivers, and so on. And we are seeing it in every single step of the food chain, from the smallest plankton up through the food chain to larval fish, seabirds, and entanglement and ingestion in species such as sea turtles. We're also increasingly gaining more insights into the potential health and actual health impacts of us eating or breathing plastic as part of our everyday lives. And all of us now have plastic in our systems. So this startling statistic is that if we don't change anything, by 2025, we could be looking at 1 ton of plastic in the sea for every 3 tons of fish. So these are fairly startling statistics, and this is all relatively recent in the context of our time on this planet and on the planet ocean's existence. But I think the key thing that is recognizing that while this is an urgent environmental crisis, that is global, it's visible, it's harmful, but also it's solvable. And some years ago, some colleagues and I got together to think about how we start sharing solutions, and came up with a hashtag Ocean Optimism. And that's really trying to provide a simple tool to be able to share the positives that we see wherever we go in the world of people doing great things to help sort of conserve the ocean, even though we are looking at a very serious global situation. The way that I'm really interested in finding these solutions is through collaborative and interdisciplinary science. I think in science, it's very easy to get stuck within your discipline quite quickly. It's how you choose what conferences you go to, what papers you read. You never feel you're reading enough anyway. Your networks you develop tend to be around your core topic, and it can be quite hard, particularly as things progress, or even when you're a student, to break out beyond that discipline. And some of the research I'm doing as leading the Bertarelli Foundation's Marine Science Programme is looking at how insights we get from interdisciplinary science, to sort of see how that frames the work that I've been involved with, and to show that that you can have what looks probably on paper, and my publications is quite a random career, has really been focused on finding conservation solutions. So my PhD is in fish population genetics. that then went on to look at seahorse population genetics and seahorse species identification. So having worked on seahorses for many years, you can imagine that seeing this image of a seahorse floating through the ocean clinging to a cotton bud really struck home. Plus, looking at the places that we were working, primarily in the Philippines, around seahorse conservation, which are islands just like these, where you can really see the local pressure on ocean resources, but also the local dependency on those resources. And what we see is that over time, we're seeing that overfishing leads to the loss and decline of fish stocks. And so in response, there's more and more fishing effort. And fishing effort leads to more and more use of different kinds of fishing gear and fishing nets, bigger nets, longer nets, nets with smaller mesh sizes, more and more nets. And one thing around nets is that most of them are made of plastic. So the global estimate is about 640,000 tons of nets being discarded every year. This is nets either accidentally being left behind or purposely discarded at the end of life when they are beyond repair. And these cause havoc in the ecosystem. They continue to catch fish that benefit nobody, and they can wrap themselves around key habitats like mangroves. And they just don't go away. So while we can use plastic for a short period of time, single-use plastic maybe a few minutes or a few seconds even, plastic persists in the environment for hundreds or thousands of years. So in these islands in the Philippines, where you have zero waste management infrastructure, you see images all so common like this, where you see the accumulation of nets on beaches along with other waste items, but in this case, you're seeing that nets are a very dominant item. However, fortunately, one person's waste is another person's treasure, and many of these fishing nets are made of a material called nylon 6, which is a very high grade material and has a high value within the recycling sector. We were able to build a partnership with two key organizations. One is Econil, which regenerates nets into yarn, which is used then to make clothing, and Interface, which makes carpets, which is the other main use of this yarn. So we take a product that's a waste net. It is regenerated into a material using this chemical regenerative process, which means that the performance is exactly the same as if it came from fossil fuels, which is the normal source of plastic yarn used in things like carpets. So all we had to do was to connect these lying on the beach waste nets into this global supply chain and to make it work as a business model. So looking at the value chain and with the primary goal of really benefiting the communities at the front line of dealing with this waste. So we established a system where we would pay communities a certain price per kilo to collect, clean these nets. We developed a non-electricity system to bale the nets into more economic and manageable bundles, to take them to an aggregation point where they could be pulled together and then transported. Now, this is one truck of a number of trucks for one shipment, but if you just for a minute realize that all of these would have been waste nets just in one small part of the Philippines, it's quite a striking image. They then loaded into containers, regenerated into yarn and made into carpets. To make this whole financial transaction process work, we used a self-help savings group system known as Village Savings and Loan Association. So that's sort of powering the system of buying and selling the nets and helping establish the community institutions to set up this business model. From a research perspective, we've been monitoring the beaches and seeing that over time, these are significantly cleaner, because as soon as the nets have a value, they no longer get thrown away. And we actually move from a system where the nets are going straight at the end of life. Instead of being discarded, they go straight into the supply chain. So they never actually get thrown away at all. So we started this with a pilot initiative in 2013. We have expanded it and sort of established it since then. And since we started, that's collected and exported over 300 tons of nets, which is enough to go around the world over 10 times and benefiting 64,000 people in local communities. But not every community does have lots of nets, or sometimes it's difficult to have enough to justify setting up the infrastructure to collate them. But what we've been doing more recently is establishing a diversified business model into seaweed farming, which has many other benefits, as we know. But this is for carrageenan, which is a product that's widely used in many food products and even fire retardants for ice cream, toothpaste, lots and lots of other products. So with using the same principles, we've diversified into seaweed farming and connected all of this to marine protection. So this is linking the business model with marine protected areas. So we not only have less plastic, but we also have healthy, more secure communities and more fish. So the overall initiative looks like this. It's a social enterprise is called Coast for Sea. It started as a research project within ZSL and is now a standalone business that has just received its first impact investment, bringing together this social infrastructure, seaweed farming, net collection, marine protected areas, and connection to responsible global markets. So that's one solution that we're looking at. But as I mentioned, we know that plastic doesn't recognize borders or boundaries, and plastic floating through the ocean doesn't have passports. So we're also interested into looking at the flow of plastic. And some years ago, in 2017, there was a paper that talked about 10 rivers contributing much of the plastic that was coming from rivers into the ocean. And at the same time, National Geographic had become interested in looking at this particular issue with a really iconic magazine version, which showed some very dramatic imagery of the impact of plastic on our planet. So they pulled together a sort of an advisory group workshop, which ended up suggesting that we pilot, or we really investigated the plastic flow from rivers into the ocean by doing an expedition to the river Ganges, the Ganga River, or the Padma and Meghna in Bangladesh. So the idea of this was to collect empirical data on the ground to really understand the types of plastics, the flow of plastics, the load, and how it was moving through the system. Now, this river is really an iconic river, but quite dramatically different. So at the source, at the point where it meets the sea in Bangladesh, it's about 7 kilometers wide. It's very much like working on the ocean. And when you get to the source, it's right up in the Himalayas. So it's very much working with a glacial melt stream. And we traveled the length of the river twice. This was in 2019, so just before the global pandemic, from the sea to the source. And the reason we did it twice was to look at the difference pre and post monsoon. The earliest review paper was my first co-publication with Subrata, and other fantastic colleagues from Bangladesh and internationally, looking at what the state of knowledge was now and really recognizing that there's huge skews in different areas and there's very little known about what was happening with plastic pollution in Bangladesh. So we were filling a big knowledge gap. Sadly, Subrata's not in this picture, but this was the team that set out. We also looked to provide opportunities for women in science to participate in field work and to bring together a really interdisciplinary team. So we had technology experts, plastic experts, storytellers, ecologists, social scientists, anthropologists, biologists, ecologists, and so on. And because the scale of the challenge was so great, we came up with a standardized sampling protocol that we implemented at 10 sites, the length of the river. And this is really looking at a rapid assessment, but developing tools and techniques that could be applied and replicated elsewhere. So we looked at sampling on the land, on the water, and also with communities. This involved sampling water for microplastics, also sediment. It involved sampling microplastics in the air, looking at the impact on wildlife, and particularly around the use of plastics and nets in fisheries, and holding focus group discussions and household surveys. We mapped the sort of infrastructure that was the sort of formal waste management systems, but also informal dump sites like this, and the litter on the ground. And one of the primary tools we used for this was an open data app called Debris Tracker, which you can use anywhere in the world, and has various lists in different languages that you can use, or you can ask the developers to set up your own list if you're particularly interested in tracking your own kinds of plastic. This also gave us a great tool to engage with local communities and schools and school children in terms of really moving plastic from being a kind of wallpaper that everybody ignores to actually looking at diagnosing the different kinds of litter. And with this open source data, you can go and look at the map and see the number of plastic items recorded at each location. You can see our kind of ripple effect of connecting with other people in other places, but also diagnose each of those types of litter and which were the most abundant in each location. From the microplastic samples, we recognize that up to 1 to 3 billion microplastic particles per day could be coming from the river into the Bay of Bengal, which really emphasizes the importance of trying to stop plastic getting into the river in the first place through the various routes, because trying to manage that kind of input from freshwater systems into the ocean is obviously hugely challenging. Using the similar methods that we'd used in the Philippines, we also identified that fishing gear is a significant source of plastic pollution. That was of great concern to communities and also had potential impact on wildlife. And we learnt more about the community insights to the major challenges of dealing with plastic pollution, but also looking at alternatives. And some of the challenges of switching to alternatives relate to the cost, the availability, and things like financial and time constraints, particularly looking at it with a gender perspective. We also were very interested to look at understanding how plastic moves through the system and to try and collect some empirical data on that. So we worked with a technology expert, a guy called Al Davis from Aribada. This is Professor Gausia Chowdhury from the University of Dhaka, who led the Bangladesh expedition. And we developed an open source tracking technology basically wrapped up inside a 500 milliliter plastic bottle. The idea of this is that it sends a location signal sort of as many times as you want, but obviously that affects the battery life. And we tested having a mobile phone SIM inside to send a text message when it was in signal, and then when it got out into the open ocean, that it would send using the aerial on top by satellite. The first prototype of this, we found that one of the bottles moved about 3,000 kilometers in 3 months, headed out to sea. That was one that was actually deployed right at the point where the river met the ocean. And a number of the bottles were trapped inside the river, went up tributaries, and that really gives some practical and empirical data to support what we're starting to see, that yes, a lot of plastic is flowing from rivers into the ocean, but also rivers are reservoirs for plastic, and a lot is being trapped. So the outputs of this expedition were twofold. We developed a summary report, which includes a number of scientific papers that came out of it, that are all open access, available online, and a methods toolkit with the idea of providing a really simple to use and accessible approach to using exactly the same methodologies that we did for people who are interested in looking at documenting plastics and plastic pollution in their systems. So what's really exciting was, on the basis of these findings, that we were, and this is continued collaboration with Subrata and the team at University of Dhaka and Wild Team, we received further grant to take forward the replication of the net recycling project, particularly looking at it from a gender perspective in communities in Bangladesh. So we did some initial mapping of what was known from government records and from the data, available data, to look at hotspots of where fisheries and fishing nets were most likely, and conducted some field visits. These were implemented by local partners, because at the time we were in the heart of COVID restrictions and unable to travel. The team were unable to travel to the field, but really sort of established some of the information about turnover of nets, and came up with a value chain model to look at how we go through these different steps of collection, buying, cleaning, sorting and baling, and shipping. We're right now starting up the next phase of this, which is filling in some of the data gaps. Subrata's been leading work looking at the materials that nets are made of, and finding most of them are nylon 6, at least to some percentage, and working with communities to look at the rates and turnovers and quantities of nets to look at the viability of this model, as well as the operational logistics and costs of establishing it. The second sort of next step I wanted to talk about, so in addition to replicating that element of the project, we have been progressing the pollution tracker technology. So this is what they look like in the ocean. They're deliberately coloured quite dark, so they don't really stand out, so they don't get picked up by anybody who's particularly curious. And realised that obviously it was quite challenging with the tech colleague being based in the UK. We decided that there was a big political event, the G7 summit in the UK, based in the UK last year. And we decided that it would be an interesting way to highlight to world leaders that we do have one ocean, that plastic pollution is a problem and it gets everywhere. And we need to really look at how to address this at source. So we deployed 7 trackers named after each of the G7 countries. This is online, so you can go and look at these models and tracks. You can see that some of them just went short distances before they beached, and others were at sea for over 150 days, doing very, very convoluted routes. just at the UN Ocean Conference 2 weeks ago, that was in Lisbon in Portugal. We repeated the same awareness raising and scientific experiment to look at this by deploying a series of bottles from the beach near Lisbon. And you can see that, well, they went 200 kilometers within the first week. This is a little dated, but they're now, it looks like possibly 2 might head into the Mediterranean or beach off the south coast of Spain, and 1 is heading towards Morocco. So this has been a fantastic tool to look at how plastic pollution is actually moving through the ocean. And I have a master's student with a colleague, a physicist and oceanographer at the University of Plymouth, Phil Hosegood. What we're doing is working with him and James Wright at the Plymouth Marine Laboratories to use local oceanographic models to look at that linked with wind and weather data, and look at how the bottles actually perform compared to how they would be predicted to perform in the model. This is a very early image from the students, so don't just, that's just to show science basically. But that is being worked up and is due for completion in September. So that will give us some really interesting understanding, appreciating there's only sort of 7 of these bottles and we're still looking at quite small numbers, but is going to give us some insight on how we might structure deployment of those going forwards. And that same collaborations with the colleagues at Exeter are deploying some of these bottles as part of a Southeast Asian research project across Singapore, Malaysia, and Thailand over the coming months. So this seems to be a tracking technology that is being widely used. I should say that one of the key criteria are that these are cheap. They're just a couple of $100, and that they are open source. So there is fully published data if you wanted to build your own bottle. And just to think about how we employ this more widely. So one of the areas that I work as part of the Bertarelli Foundation's Marine Science Programme is the Chagos Archipelago, right in the middle of the Indian Ocean. Only one of the islands is, there's about 55, there's only one of them is inhabited. And so it provides a very interesting opportunity to look at this as a reference site to compare to other places which are perhaps more impacted or populated. So this was me in 2016 on a beach after 20 minutes of collection of plastic. We've done further research since to show that plastic bottles are one of polystyrene and flip-flops or slippers are one of the dominant plastic items on the islands in this particular archipelago. And this was an initial thing that we just did to sort those bottles. You find that they're unlabeled, but we have now documented about 17 different countries by looking at the labels that these bottles come from. And so this is what the strand lines of these uninhabited beaches look like. But it's really key for us to understand the impact on wildlife and also how in an uninhabited archipelago do you go about mitigating this. Our focus is on turtles because this is a critically important nesting site for both green and hawksbill turtles. So we're trying to understand whether the plastics on the beaches affects nesting success, whether microplastics in the sand affect incubation temperature, which then will influence the sex ratio of turtles, and whether turtles are ingesting or different life histories. You can see the bottom right shows a turtle which has got a line that it's swallowed with a hook on the end. But to understand the movement of these bottles, obviously many of them are unlabeled, and a collaborator at the University of Cape Town, Dr. Peter Ryan, has developed a method where he's actually realized that even if the label has gone on a bottle, there's many other clues or information as to where the bottles have come from. That might be a barcode, a logo, various marks on the bottles. And so in a research visit at the end of last year, we sorted several thousand bottles into different brands, into different countries of origin, into different manufacturers, and have just a team in the field who have just coming back today, actually, who have been doing a follow-up work on this. So the idea is that this will sort of give us some empirical data of what bottles are landing there. We are combining that with oceanographic models to look at possible routes and transfers. And obviously these kind of data, because they definitely don't come from there, are going to give us some insight into how we can have policy conversations with either the brands who have produced much of this waste and with the countries where they're coming from. So watch this space on that one. We also hope to, based on the findings, start to think about potentially deploying some of the bottle trackers to ground truth some of the observations that we have from the beach litter. And I have a PhD student who's also working on the potential impacts of microplastics on filter feeding species such as manta rays. And so she's just been out collecting the first microplastic samples and matching that with existing data on manta distribution and linking that with models of plastic movement in the Indian Ocean region. So that's a quick romp through some different areas of work, and please feel free if you have to ask me any questions. Thank you very much.
Thank you very much, Heather. It's quite an impressive presentation, lots of images, breathtaking ones. I will open for questions now from the audience. If you would like to raise your hand and use the reaction buttons, raise your hand or write in the chat. Anna?
Hello, can you hear me? Yes.
Yeah.
Hi, thank you so much. I joined just a little bit in the end because I had an overlapping meeting, but it was really interesting. And I was wondering, Heather, with the data that you get from the bottles and the origin of the bottles, probably also related to the origin where they were lost. Could you overlap also with the roots of migrant animals? So, for example, the turtles or any other large fish or large mammal. Could that be related? Could that be interesting? I don't know, what are you planning to do also with that data?
Yeah, absolutely. So yeah, there's different ways of overlaying it. Obviously, with the physical bottles themselves, we're obviously just got them at the end. So we've got, you know, we can, and there's been some interesting work looking at the input from ships, because obviously some of it is going to be deployed going into the ocean at sea, even though that's not allowed, and then some of it is going to be coming from land. So then we have the models, then we have animal tracks, and then we'll obviously have these the bottle tag, the pollution trackers tags. The thing I meant to say actually is what we're starting, and it would be really interesting for anybody who has ideas in this group, but we've obviously crammed a lot of technology into a small bottle, and that was part of it, and it has to float like a bottle, it has to sort of be level, but we're thinking about what other data gathering gadgets we could put on it, you know, because as they float, you know, would be the priority be temperature, or we've had somebody who's very interested in bioacoustics and looking at acoustic monitoring, but I'd love to have any thoughts that you might have as to what would be your priority if you were to add something else onto this tracker. So as it's floating, it's not just doing movement data, but we can potentially add other stuff onto it. And then we have behind the back of house of the data that it's producing is basically every time the satellite passes, which varies a little bit per day, but it gives a GPS location. We're getting about 5 location points every 24 hours, and the batteries at present will last 2 years on that trajectory. You can obviously ramp that up, but the batteries will last longer, less. And so one of the next iterations we're looking at is, can we get them solar powered? So but that again, if you're adding additional recorders, you're going to be trading off with power requirements. Does that, sorry, that was a longer answer. I went off on it because I meant to say that. I was thinking I've got this amazing crowd of people together, of experts that I need, and I completely forgot to say that bit. So thank you for giving me the opportunity.
That was good, thanks.
That's so interesting. I'm no biogeochemist, but I would guess that anything related to seeing per source of carbon dioxide, something like partial pressure of CO2 would be something very interesting to have it collect. I mean, temperature is the most obvious and probably cheapest sensor you can get, but of course we have plenty of other devices that do it, but perhaps partial pressure of CO2 is something. Nandini.
Hello, Heather. And that was a wonderful talk and tremendous effort that you have put in. Congratulations for doing such an extensive work. Really impressive. And I have a quick question. You said about the technology that you developed for processing the fishing nets, the ghost gear. Is that are you able to transfer that technology to other parts of the world also? For example, to India or to one of our study sites?
That's a really great question. I mean, that at the moment that the only factory in the world in this technology, and it wasn't technology I developed, is in Slovenia in Europe. And it's basically, it starts off as a net, it goes into like a big melting, literally a melting pot, and then it goes through various fractionation processes until it then is spun as yarn. So you're talking, you know, very expensive infrastructure, but we're starting to see expansion of that, and actually different, there's also mechanical recycling as well, which is more just sort of either melting or chopping up or squishing the net. So at the moment, one of the things that Subrata and I are doing with our collaborators, and that includes collaborators in India with the Wildlife Institute of India, is looking at where are the different markets, like who's buying the nets, either locally or what possible supply chains are there. So it may be there are other opportunities within the region where you don't have to ship them so far. Please share details. I'm sure if Subrata has them, then we can definitely keep in touch, but hopefully that's something I'll be able to answer better in the next few months.
Thank you. And you intend to patent that?
Well, the supply chain, the system that we're setting up, which is basically just to get the nets to whoever's going to buy them. So first of all, it depends how much people will pay for them, because you've got to kind of cascade that back to the price that you can pay communities and the logistics of getting them there. We already have replicated that in Indonesia and Cameroon, and so we have a toolkit that's available. We're working on that, but obviously every situation is a little bit different, which is why, and also, so things like the learning from the work we've done in Bangladesh, where we're particularly keen to look at how women can be part of this initiative, is whether that's concerns around safety for women, of how we make sure if they're collecting nets, it's going to be relatively close to the household, or they're doing it as a group, looking at the household hierarchies and what permissions are required, as well as looking at the actual quantities of nets. So there's obviously quite different local situations of culture, and that's why this is very much, I'm talking about it, but this is very much driven by my amazing partners in Bangladesh, because it is really that local expertise, the local knowledge, the local researchers. So my sort of role in this is facilitating that transfer of knowledge and opportunity from one part of the world to another. And the same in the Philippines, it's led by our Filipino ZSL colleagues in the Philippines. So we're trying to set it up to say, right, this is this situation, and then please have a look at how it might apply, and then what knowledge gaps you would have to fill to replicate.
Yeah, yeah. In fact, we are also starting. We have started in a small way to work in this sector, and in this part of India, the plastic collection is not at all organized, and we are also focusing on the women's self-help groups.
Oh, amazing. Oh,
yeah.
Which part of India are you in?
Southwest.
Southwest, okay. I will connect you with my colleague Shrishti Patel, who is working with the partners in India, but she's that's again continuing the river-based work, but I'm sure she would be very happy to have a more detailed conversation with you, because she's the expert on that side of things.
Oh, that'll be great. Thank you. Thank you very much.
If you, if you could either drop your email in the chat or send me afterwards, that would be great.
Okay, I'll get in touch with you, because Lika.
Yes, of course.
Her, email is given there with the NANO announcement.
Yeah, perfect. Yeah.
Not Heather May, but I can definitely put the two of you in contact just after this.
Okay, thank you. Thank you.
Thank
I won't keep participating. Yeah, okay, thanks.
It's in the chat. My email's in the chat. So if
thank you.
There's any follow-up questions, please share.
Thank you. Thank you. Bye.
All right. Any other questions, Heather? While they're thinking, Heather, I wonder. So the work with the Philippines on collection of the fishing nets started in 2017, right?
No, it's still ongoing now. Yeah.
No, I was on what's the evolution, or have you seen this? I suppose this started in one island or one fishing village, and do you see the movement or the interest of the neighborhood on taking such process? And
yes, in the design, it has to you obviously have to get enough net. So basically the shipment is in kind of 10 tons. So that really depends on the local fisheries, and the good thing about nets is they don't they don't degrade, so you can just aggregate them and store them until you have enough. But basically we more look at them, we call it like a hub, which may be 13 villages in one location and 25 in another, but they're basically all feeding in to provide enough nets that we can bail and then export. So the business model and built into the finances is having the salary of a local coordinator who is facilitating, the nets, and in the self-help groups there's usually a net manager, and they'll be the ones sort of coordinating the local trade and collection, and then it gets aggregated. So that's how we get to the sort of 64,000 people and growing, because oh crikey,
sorry.
Yeah, so there's so that's how it scales. So we basically have multiple hubs operating, then we've tested it internationally, but implemented by others. So that again has been very much like the Bangladesh example, where there's the Philippines team are advising the team in Bangladesh, and so on. So we're looking at that model to replicate. And then the other thing has been diversification, which has been to go to the carrageenan in from seaweeds as well. So some communities are trading both nets and seaweed, some are just nets, some are just seaweeds.
And just out of curiosity, so I suppose that mainly you can find, like the pictures you sent us, you showed us was scary, the volume of fishing nets. But I suppose that you can find other plastic items with it. So what do the collectors do with the other items?
Yeah, that's a great question, and that's exactly what the communities say. It's like, thank you, that's got rid of one, now what about all of this stuff? We initially looked at whether we could, because the value is in the net. I've lost my train of thought now. What was the question again?
Was what were they doing with the other items?
Oh yeah, other plastic. So firstly, we looked at PET bottles, which also are quite easily recycled. Actually, on many of the islands, the bottles never get there. Liquids get dispensed into plastic bags before they get to the islands. So the route we're piloting is actually trialing a refill scheme that's led by women groups on the island. So they have some investment, some microfinance from the self-help savings group to buy products in bulk and set up refill containers that people can come to shop. So because the sachet economy, the small sachets are so dominant, but they're also very much designed for people who can only afford in that quantity, and they're very efficient in that way. And obviously you don't get degradation of the products, etc. But obviously that's very damaging, and they're very difficult to recycle as multi-layer film. Actually, that's part of the project that Subrata and I are currently working on, is also to look at the number of sachets, as Unilever, one of the biggest producers, is interested in whether they can start to look at a collection scheme. So with that particular item, we'll hopefully have some options. And that's very much around the work in India we looked at, was a series of different alternatives. So whether it's training people to make their own soaps and shampoos that can be used instead, bulk schemes, and in some cases, a lot of the solutions lie in the way it used to be. 20 years ago, there was no plastic. So what was the alternative? It was, basketware, clay cups, the different items are all in living memory. So it's understanding what the challenges are of reviving those. Is it cost? Is it local makers? Is it materials, etc.? So that's all the work that we're doing at the moment.
Well, it's a great work, Heather. Thank you so much for doing it and for sharing with us. It was really great to have you here. Thank you so much.
Very much a team effort. So I'm very much a spokesperson for all of the amazing people that I work with. And I think that's the big thing for me, is the joy of collaboration and working across disciplines and internationally. And I think that's what's lovely about the network you have here. So keep up the good work, everyone.
Yeah. All right. Thank you so much. And thank you, everybody, for joining us. Thank you, Subrata, and all of you. This is being recorded, of course. We will post it on YouTube later on. So we encourage you to watch, and we encourage you to visit. I can't remember the website, Heather. You put it in the end.
Yeah, that's only one bit of the project, so I probably need to share some others.
Well, look for the hashtag Ocean Optimism,
yeah,
right?
For sure.
For more information.
And use it when you find a great solution.
We will. Thank you so much, and have a great weekend, everybody.
Thank you, Heather.
Thank you. Thanks,
Thank
everyone.
you.
Thanks, Marta. Thanks, Lillian. Nice to meet you all.
Nice to meet you.